Hello, my name is Adrian Rodriguez, and here is my final circuit for Project 2 of Dr. Khan's. In this circuit, we are using a thermistor to determine the temperature in the room. Now, the way this circuit works is if the temperature in the room is below 80 degrees Fahrenheit, this blue light will be on. And if the temperature in the room is over 80 degrees Fahrenheit, this red light will turn on. Now, how this circuit works is it is all controlled by this microcontroller. Now, a microcontroller actually doesn't read temperature at all. Now, you may be asking, well, how is this going to work then if we're trying to determine the temperature of the room? Well, the way this works is the thermistor's resistance is actually controlled by the temperature. So the thermistor's resistance is controlled by the temperature, and that in turn affects the voltage output. So the microcontroller gets the voltage output of the thermistor and stores it as discrete memory. From there, we can go in and put in a program which converts that discrete memory into resistance, and from resistance to temperature in Kelvin, and from temperature in Kelvin to temperature in Celsius, and then finally from temperature in Celsius to temperature in Fahrenheit. So if we go right here, I'm just going to explain briefly my code. I'll go more deep into depth on my report. So we start with our three variables that we got from the thermistor manufacturer, and then right here we put our inputs. So these are basically where we're going to be putting our two LEDs, so that way the system can know which light to turn on if either of the conditions is met. So if the temperature is below 80 degrees Fahrenheit, it will tell the circuit to turn on the blue light. And if the temperature is over 80 degrees Fahrenheit, the circuit will turn on the red light. And then right here is basically our formula that we are using to convert the voltage that the microcontroller is getting into resistance, and then from resistance into temperature in Kelvin, and then finally from temperature in Kelvin to temperature in Fahrenheit. So ultimately, that is how our code works. Like I said, again, I'll delve a little deeper in my report, but overall, after we plug this code in, we can now, once we plug the code in and upload it to our microcontroller, we can now see the temperature in the room. So we'll click on our serial monitor here, and we'll see that the current temperature in the room is 76 Fahrenheit. So right now the blue light will be on. But for all intents and purposes, let's give the thermistor a little bit of heat with my finger just so we could see the red light turn on and so it could go over 80. So I'm gonna put my finger on it. So my finger is on it and we see it going up. So it's well over 80 now, and now the red light is off. So the red light is on, I take my finger off, so the red light's on. I'm gonna take my finger off. It's going to start dropping, and let's see. So once it goes below 80, it is now back to blue. So see how it went below 80, so it went back to blue, and let's just get it back up to 80 real quick just so we could see it. Right. So we got it back to 84, so it's well over 80, and now it's red. And we take our finger off, so the temperature begins to drop. It's still red because it's still well over 80, and as soon as it drops below 80, it's going to go back to blue. It drops below 80, and it's back to blue. Now, another way to view the temperature is by also using the serial plotter. Now, the serial plotter is basically the same thing as telling us the temperature in the room, but it's plotting it for us. Now, what you're seeing here is the same thing you're seeing here. Now, what these lines represent is when the line is going straight, that means the temperature is constant. That means the temperature is not changing. So you see how it's going in a straight line? That means the temperature isn't changing. So you see how the temperature is staying constant? So we'll see a straight line. Now, when the temperature is rising, you're going to see the line shoot up. I'm gonna put my finger on the thermistor just so we could see it shoot up right here on the plotter. So I'm gonna put my finger on the thermistor. So temperature should be going up, and look, you see the line going straight up. So when temperature is going up, the line goes up. I'm going to take my finger off it so we could see what happens when temperature goes down. The line is going to go down. So I take my finger off, and you see the line going down because temperature is dropping. So when temperature is constant, straight line. When the temperature is rising, the line is going up. And when the temperature is going down, the line is going down. And ultimately, this is how we use a thermistor to determine the temperature in the room. This is a great way, and it teaches us how thermistors work. Thermistors are used in thermometers as well as in other appliances, such as our iPhones, for example. Our iPhone has a thermistor which tells us if our iPhone is getting too hot, and it sends us that message letting us know that our iPhone is overheating, and it shuts it off. And these are just everyday examples of how we use thermistors. And then I'll delve deeper in my report on more or less the formula that we used and the variables that we had to input, and then the relationship between voltage, resistance, and temperature, and how we got to the final temperature to display it, and my final circuit. So everything plugged in. So again, below 80, blue light. Let's get it. Over 80, red light. Temperature is rising, so the line's going up. Gonna take my finger off. Temperature is dropping because temperature is going down, and then if temperature is constant, you're just going to see a straight line. Let's see if it evens out. So it's still dropping, still dropping, still dropping, still dropping. The temperature's still dropping. So yeah, if we see, look, see, it's kind of dropping a little bit. Oh, now it's kind of evens out. So look, see, so it's slowly evening out. So look, as it starts giving the same temperature, you'll see the line going straight. So that means the temperature is staying constant. And yeah, thank you so much.